Dear students, welcome to physics class of U1. In the chapter laws of motion, in the previous class we have discussed about the advantages and disadvantages of friction. Friction is a necessary evil, and what are the important methods for reducing the friction. These points were covered in the previous class, and also one more important point, that is about the centripetal force, right? What is centripetal force? That one we have discussed in the previous class, which is necessary for a circular motion, right? For a circular motion, the centripetal force is necessary. What is the centripetal force? The radial force which is acting on the object directed towards the center in case of a circular motion, that is called as the centripetal force. And the expression for the centripetal force is F is equal to mv square divided by r, right? Where r is the radius of the circular part, m is mass of the object, and b is the velocity with which the object is in a circular part. Now, the next point we will discuss about the banking of rods. That means about the circular motion. The examples of circular motion we are discussing by taking an example of banking of roads, right? The motion of vehicles along a curved is also a circular motion, right? The motion of an vehicles in a curved path, that is also a circular motion. The centripetal force which is needed for the circular motion in case of the motion of vehicle, it is provided by the force of friction between the road and tires, right? The necessary centripetal force is provided. The necessary centripetal force is provided by what? The force of friction between the road and tires, right? But if the vehicles move with a high speed, right? For example, if the vehicles are moving with high speed at the curved path, the force of friction between the road and tire, which is not sufficient to pass the curved path. So in that case, what happens? The vehicle may skid it, right? There may be a possibility of skidding of the vehicle. So to avoid the skidding of the vehicles at the curved path, the roads are banked. So what we call it as the roads are banked. So why the roads are banked? If the vehicle is moving with a high speed at the curved path, right? In those cases, the force of friction between the road and the tire is not sufficient to pass the curved path. So in those cases, the roads are banked to avoid the skidding of the vehicle. So then, what is mean by the banking of roads, right? What is mean by banking of roads? The process of raising the outer edge of a curved road above the inner edge to give the necessary centripetal force. That is called as the banking of road. So what is mean by banking of roads? The process of raising the outer edge of the curved road, right? The process of raising the outer edge. The process of raising the outer edge of a curved road. Above the inner edge, right? The process of raising the outer edge of a curved road above its inner edge. Above its inner edge to give necessary centripetal force. To give necessary centripetal force is called banking of roads. Banking of roads. right? The process of raising the outer edge of a curved rod above the inner edge to give the necessary centripetal force is called the banking of rods, and the angle through which the outer edge of the rod is curved, that is called as the angle of banking, right? So this value theta is called as the angle of banking. So as you have observed the curved paths, right, like this, the roads, right? So this is the inner edge, and this one outer edge, right? The inner edge and the outer edge of the road. So this is the curved path. So this may form a circle here. So this may form a circle here. So that's why it is called as a curved path. Curved path motion. It is also a circular motion, right? The process of raising the outer edge, right? This outer edge is raised little bit, right? The process of raising the outer edge of a curved road above its inner edge. Inner edge ಗಿಂತ outer edge ಏನು ಮಾಡಿದ್ದಾರೆ, slightly height ಮಾಡಿದ್ದಾರೆ, right? To avoid the skidding of the vehicle if it goes the maximum speed, high speed, right? And also to provide the necessary centripetal force which is required for circular path here. So in this way, the process of raising the outer edge of a curved road above its inner edge. So inner edge ಏನಿರ್ತದೆ ಅದಕ್ಕಿಂತ outer edge ಏನು ಮಾಡಿರ್ತಾರೆ, slightly height ಮಾಡಿರ್ತಾರೆ, right? So above its inner edge to give the necessary centripetal force is called as the banking of roads, right? This is called as what? The banking of roads. Now what is angle of banking? What is meant by angle of banking? The angle to which outer edge of the curved road is raised. The angle by which the outer edge of the curved road is raised. Now west angle in the outer edge and raise ಮಾಡಿರ್ತೀವಿ. ಆ angle ಗೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು? That is called as what? The angle of banking, right? The angle by which the outer edge of the curved road is raised, that is called as the angle of banking. Angle of banking. The next point we have to derive here the expression for the circular motion of a car. The expression for a circular motion of a car on a banked road. That means we have to derive here the expression for the maximum safe speed, right? The maximum safe speed of a car on a banked road in circular motion, right? So when the vehicle is moving in a curved path or a circular path in a banked road condition, what is the maximum speed with which the vehicle can pass the curved path? That expression we have to derive here. So let us consider here the vehicle or the car which is moving on a road of radius r, right? A circular path, curved path of radius r, and which is banked at an angle theta, right? This is the path of the vehicle, curved path of the vehicle. Then the outer edge is raised by an angle theta. So this angle theta is called as what? The angle of banking, right? So now what are the different forces are acting on the vehicle or the car as shown in the figure, right? What are the different forces are acting on the vehicle or the car, right? The first one, the weight of the car, that is W is equal to mg, which is acting in downward direction, right? The different forces which are acting on the car, those are what? The first one, weight of the car, right? The weight of the car W is equal to mg, which is acting in which direction? That is vertically downward direction, which is acting vertically downwards. The weight of the car which acts in downward direction, that is W is equal to mg. Again, the normal reaction which is acting in the upward direction but which makes an angle theta with the vertical, right? The second one, normal reaction. Normal reaction N, right, which acts in upward direction but which makes an angle theta with the vertical. Makes an angle theta with the vertical. So therefore we resolve this being normal reaction only vertical direction, but which makes an angle which is in upward direction, but which makes an angle theta with the vertical. Vertical cast angle what is it? It makes an angle theta with the vertical. Therefore, the normal reaction is resolved into two components. One is vertical component and another one is horizontal component. Right? Resolving the normal reaction N. Right? So vertical component is N cos theta, and horizontal component is N sin theta. So if need theta with normal reaction ಅಂದರೆ ಇದು exactly ಮಾಡಿ ನಾವು which makes an angle theta with the vertical. So it is resolved into two components. One is vertical component and another one is horizontal component. Right? Vertical component is N cos theta and horizontal component is N sin theta. Again, the friction between the rods and the tires which acting downwards along the inclined plane. So in inclination ಇಲ್ಲಿ friction act ಆಗ್ತಿದೆ along the downward direction. It also that friction is also resolved into two components, right? Force of friction, third one, first one weight of the car, second one normal reaction, and third one weight. Third one is force of friction. Force of friction which is acting in which direction? Which is acting in downwards along inclined plane. Which is acting along the inclined plane. Along the inclined plane, which is acting in downwards direction. So it is also resolved into two components. So resolving force of friction. So after resolving the friction F into horizontal and vertical component, so vertical component becomes what here, that is F sin theta, and the horizontal component becomes F cos theta. So F cos theta is the horizontal component here, right? Then vertical component is this one, F sin theta. So F sin theta is the vertical component and F cos theta is horizontal component. Right? So we have resolved all the forces. The different types of forces are acting on the car. First one, weight of the car, that is mg, which is in vertically downward direction. Normal reaction, that is n, which makes an angle theta with the vertical. After resolving it, vertical component becomes n cos theta and horizontal component becomes n sin theta. Again, the force of friction which is acting along the inclined path, it is in downward direction. This force of friction is also resolved into two components. One is vertical component F sin theta and horizontal component is F cos theta. Right? Now, the next point we have to see here, what there is no acceleration in vertical direction. Vertical direction no yaudu acceleration irangilla, right? The acceleration is only there is no acceleration along the vertical direction and the net force in the vertical direction is 0. ಇಲ್ಲಿ vehicle in the upward direction move ಆಗ್ತಿರೋದಿಲ್ಲ, right? Therefore what? There is no acceleration in the upward direction. Therefore the net force in the vertical direction is 0. ಅಂದ್ರೆ ಏನಾಗ್ತದೆ, n cos theta, right? n cos theta is equal to mg plus f sin theta. ಅಂದ್ರೆ ಡೌನ್ವರ್ಡ್ ಫೋರ್ಸ್ ಮತ್ತು ಅಪ್ವರ್ಡ್ ಫೋರ್ಸ್ ಎರಡು ಈಕ್ವಲ್ ಆಗುತ್ತವೆ. Therefore no acceleration in vertical direction. No acceleration in vertical direction. no acceleration in vertical direction. Therefore, the net force in vertical direction is 0. Therefore, what we can write here, that is n cos theta. Upward force is another, but downward force is another. It is n cos theta is in upward direction and downward is what? Weight plus this f sin theta. That is equal to what? Mg plus f sin theta. ಎರಡು equal and opposite. Right? So n cos theta is equal to mg plus f sin theta, and this we can write it as what? The n cos theta minus f sin theta is equal to mg. So call this as equation 1. Right? And also the centripetal force is provided by the horizontal component of n and f. So as we have told you what, the necessary centripetal force is required. The centripetal force is required for circular path, for circular motion of the object. So in this case, the motion of a car or the vehicle along the curved path, the necessary centripetal force is provided by the horizontal component of this n sin theta and f cos theta. ಇಲ್ಲಿ horizontal component ಅದಾವ್ರಿ normal reaction and force of friction ಅವೆರಡು ಕೂಡ ಏನು ಮಾಡ್ತಾವ, necessary centripetal force ಕೊಡ್ತಾವೆ. That is, one is what, the horizontal component n sin theta, and again this horizontal component f cos theta. These together gives the necessary centripetal force. Therefore, the next point what we can write here, the necessary centripetal force is provided by the horizontal component of f and n. Right? F and n horizontal components which provides the centripetal force. Right? The necessary centripetal force is provided by the horizontal component of f and n. Therefore, the centripetal force is equal to what? N sin theta plus f cos theta. Therefore, what we can write here as the next point, that is, therefore this horizontal component, that is n sin theta, right? The horizontal component n sin theta and this horizontal component f cos theta. ಇವೆರಡು ಕೂಡ ಏನಾಗ್ತಿದ್ರೆ necessary centripetal force ಕೊಡ್ತಾರೆ. Therefore, n sin theta plus f cos theta is equal to mv square divided by r. Right? Where mv square divided by r is what? This is the centripetal force. Where v is the velocity with which the object is moving, or in this case, your taken vehicle is moving, and m is mass of the object, and r is the radius of the circular. So from this equation, this is the equation 1 we have got, and this is the equation 2. Now we have to finally we have to derive here what is the maximum safe speed of a car on a banked road, right? So now let us divide here equation 2 by 1, right? Dividing equation 2 by 1, right? That means what? N sin theta plus f cos theta, n sin theta plus f cos theta divided by, and from the equation 1 it is what? N cos theta minus f sin theta. N cos theta minus f sin theta, this is equal to what? mv square divided by r, m into g. Right? We are dividing equation 2 by 1. This is equal to mv square divided by r. So in this equation 1 we have mg. Right? So now this m and m get cancelled here. Right? And n sin theta plus f cos theta divided by n cos theta minus f sin theta is equal to v square divided by r into g. Right? Therefore, v square divided by r into g, we write this term in this side. So now again dividing here the numerator and denominator by the term n. Right? I will divide this numerator and denominator by the term, right? By the term n. Right, by dividing the normal reaction. So the next term what we will get here, this is equal to sin theta. ಈ whole term numerator ಏನಂದ್ರೆ n divide ಮಾಡ್ತೀನಿ, denominator ಗೂ n ಇಂದ divide ಮಾಡ್ತೀನಿ. So therefore sin theta plus f ಇಲ್ಲಿ divide ಮಾಡಿದ್ರೆ n cancel ಆಗುತ್ತೆ, ಇಲ್ಲೂ cancel ಆಗುತ್ತೆ, but ಇಲ್ಲಿ cancel ಆಗೋದಿಲ್ಲ. So f divided by n cos theta and divided by cos theta minus f divided by n sin theta. Right? But what is f divided by n? What we can write there? Right? From the laws of from the laws of friction, you know that the maximum value of the friction, that is the limiting friction, is directly proportional to the normal reaction, right? Therefore we know that Fs max, or the force of friction, right, this is equal to mu s into n, right? Therefore Fs max divided by n is equal to mu s, that is the coefficient of static friction. Therefore substitute here F divided by n is equal to mu s. Therefore V square divided by Rg is equal to what we are getting here. And again substituting Fs max divided by n is equal to mu s, and again dividing the numerator and denominator by cos theta, right? Dividing numerator and denominator by cos theta. Sin theta divided by cos theta is tan theta plus mu s into this here cos theta divided by cos theta is 1. So tan theta plus mu s, and again cos theta divided by cos theta is 1 minus 1 divided by n is mu s, and sin theta divided by cos theta is tan theta, right? Now we want the expression for what here? V, that is what is the maximum safe speed of a vehicle, right? Now let us say here, therefore what we can write here, V square is equal to, or V is equal to, we have to write here, right? So therefore I will take this Rg to the right hand side. So what we can write here, V square is equal to Rg into tan theta plus mu s divided by 1 minus mu s tan theta, right? Now we want the maximum safe speed of a vehicle on a banked road, right? So V is equal to square root of R into G, that is the radius of the curved path, and tan theta plus mu s divided by 1 minus mu s into tan theta, right? So this is the maximum safe speed of a car moving on a banked road, right? The maximum safe speed of a vehicle moving on a banked road, it is equal to the expression what we have got here. Again, if you want to find the maximum speed or the optimum speed of a vehicle on a banked road, that can be obtained by putting mu s is equal to 0, right? That means there is no friction, right? Mu s is equal to 0 means there is no friction. So we can obtain by putting mu s is equal to 0, we can obtain here what? The maximum or the optimum speed of a vehicle moving on a banked road. So ಒಂದು vehicle banked road ಅಥವಾ curved path ಮೇಲೆ curved path ಇಂದ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅದರ maximum safe speed ಎಷ್ಟು ಇರಬೇಕು, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ಇಂದ ಹೋದ್ರೆ ಸ್ಕಿಡ್ ಆಗುತ್ತೆ banked road ಮೇಲೆ. ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So that can be obtained by putting mu s is equal to 0 in this equation. So V is equal to, so by putting mu s is equal to 0 in this equation, this term becomes 0 and this term becomes 0. Then Rg tan theta. So Rg tan theta is what? The optimum speed. The Rg tan theta is what? The optimum speed of a vehicle. The optimum speed of a vehicle which is moving on the banked road, right? That is V is equal to Rg tan theta. And again on level circular road, so idu theta is equal to 0 itri ಅಂದ್ರೆ ನಾವೇನು road ಅನ್ನು ಬ್ಯಾಂಕಿಂಗ್ ಮಾಡಿಲ್ಲ. So in that case what happens, that can be obtained by putting theta is equal to 0. ನಾವು road ಅನ್ನು ಬ್ಯಾಂಕಿಂಗ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕ್ರಿ, that can be obtained here theta, that is the level circular road ಇತ್ತು, angle of banking ಇರಲಿಲ್ಲ. So for level circular road, right, when the curved road is flat, that means for unbanked road, for unbanked road that can be obtained by, that is theta is equal to 0. So put theta is equal to 0 in this equation. So by putting theta is equal to 0, what we can get here? So V is equal to R G into mu s, right? So by putting theta is equal to 0, you can write V is equal to R G mu s, right? We have got here this equation, V is equal to R G into mu s. So this rj into tan theta, if you put theta is equal to 0 to 0 here, so this term becomes, so then multiplying rg into mu s, so that will get in the numerator, and the denominator also becomes 0. Mu s into tan theta is also 0, so in the denominator you will get 1. So for unbanked roads, the maximum safe speed of a car of the vehicle is rg into mu s. Then g is the acceleration due to gravity and r is the radius of the circular path. So by all these factors we have to construct the road here by considering the radius, then acceleration due to gravity, and also the mu s, that is the coefficient of static friction, right? So for banking of roads, for banked road, the expression for the maximum speed of a vehicle is equal to rg tan theta, root of rg tan theta, and for level circular road or for the unbanked road, it is equal to square root of rg mu s, right? So this is the maximum speed for level circular road, and this is the maximum safe speed for the banked road. So therefore here the equation 3 and 4, the equation 3 gives the maximum safe speed of a car on a banked road, right? Above which you are moving with the speed, then vehicle may get skid. And this one, rg square root of rg into mu s, this is the maximum safe speed on a unbanked road, that is the flat road or the level circular road. So above with which the speed you are moving, then again the vehicle may get skid. So based on these two equations, we have to calculate here what the maximum safe speed of a car on a banked road and unbanked road. So this is about the example of what the centripetal acceleration and the centripetal force, right? We take an example of what the circular motion of a car on a banked road as well as the level circular road, right? So this is about the centripetal acceleration and the centripetal force. The next video class we'll see about the next points. Okay, thank you.